Section 6.1, solving trigonometric equations. Most of the stuff we're going to do here is mostly introduction to the subsequent sections. So we're going to see more and more difficult equations in the subsequent sections. For the meantime, the first thing I want to recall that we have sine any angle alpha is always, if you remember the graphs, oscillates between -1 and 1, -1 and 1. Same thing with cosine, just keep these in mind. The value of sine cannot go below -1 or exceed 1. Same thing for cosine. What we need to answer questions is how to solve trigonometric equations. Let's start just asking how to solve sine alpha equals 1/2. So this means what are the alpha values? If you substitute them in there, their sine will be 1/2. And to start with this, let's do it in degrees first. Usually degrees is easier for students than radians. The first angle that I come across on the unit circle while I'm traveling in the positive direction is 30 degrees. 30 degrees, its sine is 1/2. Okay, 30 degrees in radians, if you convert it by multiplying by pi over 180, you get pi over 6 radians. The next angle we come across, its sine, it's 150. The 150, it's basically 180. This is 180 minus the 30 degrees. So this angle here and this are the same. So it's 180 minus 30 degrees. So another value for here is 150, or if you convert it, is 5 pi over 6 radians. Now, are there more? Well, if you travel more, you're not going to find anything in this quadrant or on the next quadrant. The next one you find, or you're going to come across, is where it terminates again at the same side as pi over 6. Okay, note here on the side, this is 270 here, 360. The 360 in degrees is the same as 2 pi in radians. So what we do here, is we found pi over 6 is one of them. So if I go pi over 6, so pi over 6, which is 30, and then I move again, one full cycle of 360 degrees or 2 pi radians, that gives me another solution. So all the solutions to this equation are going to be the ones at this point and at this point, at the blue points. So this means if I take, so let's call this alpha 1, alpha 2. If I want to find alpha 3, I would just take pi over 6 and add 2 pi to it. Right? And if I combine them, that's 13 pi over 6. If I want to find alpha 4, I take what I just got, the pi over 6, and add 2 pi, another 2 pi. That's 4 pi. And whatever that's going to be. Another one is going to be at 6 pi. So in general, what I'm doing here, I'm taking the original pi over 6 and I'm adding an even number of pi's, which is 2k pi. K is an integer. K is like a positive number for now. If you take k1, you get the first one. K0 first, you get just the original one. K1, you get the next one. K2, you get the next one. What about if I go backwards? So if I want to travel backwards, so you hit the first one, this, and then you go backwards one full cycle of 360 or 2 pi. So what I did, I went in the negative direction. I traveled in the negative direction. So it's the same thing as if you do pi over 6 minus 2k pi. So the minus 2k pi plus 2k pi, that can all be included by saying k is an integer. Because if k integer means, just to remind you, it could be 0, 1, 2, 3, etc. or -1, -2, etc. So if you take k1, you get the next one, k2, next one, k3, or -1, you get the next one, and so on and so forth. So that was the first one, like the first at this point. Now at the next point, I'm going to do the same thing, 5 pi over 6. But wait, do I have to run through it again? 5 pi over 6 plus 2k pi. You can do that, but I'm going to just generate it from the original one, which is pi over 6. How did I get from here to here? We did pi minus that. So alpha 2 was found by doing pi minus alpha 1. And that's going to be the case all the time for sine functions. So let me summarize it this way. If we have sine alpha equals sine beta, beta is the smallest positive angle that would work out in this case, which was pi over 6. This was pi over 6 in the previous example. Then we got alpha to equal pi over 6 plus 2k pi, and we proved y, or pi minus, but wait, I'm not going to put pi over 6, I'm going to just put beta for any angle beta, minus beta plus 2k pi, k integer. So this always solves all these trigonometric equations, assuming that we know the sine or the angle beta. Sometimes you're going to see in this section, if they give us a more complicated equation, how to deal with it. Like, I don't know what that, maybe 2/3 or something. It's not like 1/2 or something we're familiar with. So, in this case, what we got so far is we were able to prove a formula or find a formula here to solve sine functions. So if I want to go back and finish that problem, sine alpha or sine alpha is 1/2. I can replace alpha. If I want to solve it over in radians, is pi over 6. In degrees, you put 30 degrees. Then following the above equations, the alpha equals pi over 6 plus 2k pi, or alpha equals pi minus pi over 6 plus 2k pi. And if we summarize, if we simplify the second equation, keeping the first the same, it would be always nice to say k is an integer. That's 5 pi over 6 plus 2k pi. Okay, now this will generate all the solutions to that equation. In a lot of cases, 90% of the time, they tell you alpha is from 0 to almost 2 pi. If alpha is really given from 0 to less than 2 pi, then the way this works, you can take k equals 0, and we got alpha to be pi over 6 from the first equation and 5 pi over 6 in the second. If you take k equals 1, that will give you 2 pi plus pi over 6. That already exceeds 2 pi. If you substitute in the second equation, that already exceeds 2 pi. What about negative 1? So I stayed within the neighborhood of 0. So I substitute always 0, 1, negative 1, 2, negative 2. Now in 1 didn't work, so then it's not going to work for 2 or the ones after that, because it's going to get bigger and bigger. For negative 1, you're going to get pi over 6 minus 2 pi. That's negative number, but alpha has to be bigger than 0 or equal. So negative 1 doesn't work, and definitely negative 2 is not going to work either. So that was like a quick example about solving sine function and how to handle the equations. Now for the case of cosine, there's also same method. So if we are given cosine alpha equals cosine beta, okay, cosine alpha equals cosine beta, then alpha is going to be beta plus 2k pi, like the same way in sine, or negative beta plus 2k pi, k integer. So this is beta and negative beta. Always in the first and fourth quadrant. That's where cosine works to be positive. And the same thing in here. Here always in the first and second. That's where sine works. First and second. Cosine first and last one, which is the fourth one. So this formula generates all the solutions to any cosine function. So let's look at an example. What about if we ask to solve 2 cosine alpha minus root 3 equals 0, where alpha, so let's say alpha from 0 to 360 degrees. So when they give you 360 degrees, means they want you to have the answer in terms in degrees, not in radians. So what do we do here? We add square root of 3 to both sides. Then divide by 2. So square root of 3 over 2. Okay, square root of 3 over 2. What is the smallest angle that its cosine is square root of 3 over 2? Well, in this case, is going to be cosine. What angle is cosine this? 30 degrees. So the angle 30, its cosine is square root of 3 over 2. Square root of 3 over 2. Based on the formula I gave you earlier, that's going to be 30 plus 2k pi is the same as 360k. And alpha equals, or alpha negative 30 plus 360k. K integer. Always label that k as an integer. So whoever reads this, they know what k is. Now remember, they give us a condition on alpha. It can exceed 360 or below 0. So always start within the neighborhood of 0. So if k is 0, I get from the first one 30 and the second one negative 30. But negative 30 doesn't work. What about if I take k equals 1? In the first one, I'm going to get 390, which already exceeds 360. And the second one, 330. So that's okay. What about if I take k equals 2? The first one will be way more than 360 and the other one is the same thing. What about negative 1? Negative 1. The first one will be negative, the other one negative, so it's not going to work out. So there are only two values of alpha that would work out for the given conditions. Let's look at an example like this. Solve for sine x minus 7 equals 0 if x between or from 0 to 360 degrees. So the answers are going to be in degrees. This is similar, the procedure is similar to solving algebraic equations. So you're going to isolate the trig function by adding 7 to both sides, then divide by 4. So you get 7 over 4. But we're not familiar with 7 over 4. That's like, I don't know an angle its sine is 7 over 4. If you try to put that in the calculator, it's going to give us something here, like what angle its sine is 7 over 4. Notice something, when you get to numbers, the first thing, before you think about if there is a sine or not, the first thing I recalled, sine and cosine, they must be from negative 1 to 1. And the value of sine cannot exceed 1. But 7 over 4, it's 1 point something. So if you divide that on the calculator, that would give us, this is 1.75, which is more than 1. So we say the given equation has no solution. Has no solution. Let's look at a different type of question. Find all degree solutions to the equation sine x minus 60 degrees equals negative square root of 3 over 2. So always, the first step, can I find an angle its sine negative root 3 over 2? So this comes from the tables that we went over many times in the previous sections, or if you know the unit circle. So if you look up on the unit circle, this is sine 240. That's the smallest angle its sine is rad 3 over 2. The way you can, another way to look at it, if you think about there's no negative sign, just square root of 3 over 2. What angle its sine is square root of 3 over 2? It's 60, yes, 60 degrees. So if I put 60 here, then the negative, remember sine is positive here and here. So the first time it's negative in the third quadrant. So all you have to do, extend this and add 180 to that. That's just my way of memorizing it. So that gives me 240. So now I set the equation as sine something equals sine something else. So what I'm going to do, I'm going to solve now. X minus 60 equals 240 plus 360k, or x minus 60 is 180 minus, I'm using the formula I gave earlier, plus 360k. Always k integer. K integer. But don't leave it like that. We need to simplify it. So what I can do in the first one, add 60 to both sides. That gives us 300 plus 360k. Add 60 to both sides. Well, that will give me 240 minus 240. That will cancel out. And that's what it gives us. These are all the solutions. That's what it says. Find all degree solutions. All degree solutions to this equation. So these two equations will generate all the solutions for us. All the solutions. What about if we are asked to solve equation in this form? 3 minus 7 cosine x minus 2 equals 8 for x. If you solve for x, if x between 0 and 2 pi. We have to watch carefully for this problem. The first thing, as I said before, trigonometric equations, they follow the same method as algebraic equation. We need to isolate the variables. So here is the cosine part. So the first thing I would do is subtract 3 on both sides. So when I subtract 3, that gives me 5. Then divide both sides by negative 7. So it's negative 5 over 7. Now I'm facing another equation that I'm not familiar with, that 5 over 7. If it's 0, negative 1, 1, 1 half, square root of 3 over 2, square root of 2 over 2. Those ones are okay. We are familiar with those numbers, but not negative 5 over 7. Another thing, is that bigger than 1? No, it's not. Is it less than negative 1? No, it's not. You can divide on the calculator and see it. So then what are we going to do? Do we leave it like this because we don't know it? The answer is no. If you remember from before, if you have cosine alpha equals something, then that alpha is cosine inverse of that number. Okay, cosine inverse of that number. And let's watch step by step, how do we solve this kind of equations? Okay, step by step. So what do we need to do here? Remember, the answer was, the condition that was given in this problem, it's in radians, in radians. So, but I'm going to do it in degrees. It's always easier for students to visualize it in degrees, and then you can convert the stuff into radians at the end. Converting is very easy. So that's why it's easier to work with degrees first and then radians, regardless of what the condition given in degrees or radians. So let's see. First thing, we're talking about a cosine value of an angle that is negative. Where is cosine negative on the unit circle, let's say? It's negative in the second quadrant and third quadrant. So I want to find those angles that makes cosine negative in these two quadrants. How do I do this? Well, we do need to use the calculator. So the first thing is make sure the mode is in degrees, because I decide to work in degrees. So if you go to the mode in your calculator and check it, it's in degrees, you are going to insert cosine or find cosine negative 5 divided by 7. That will give us 135. So I'm going to write this here, about 135.58, up to 2 decimal places. But what I'm going to do before I move further with this is about 135. So if I want to draw it 135.58 degrees. Before I move on to this, whatever answer I got in the calculator, just keep it as is and multiply it always, whatever you have in degrees. If you multiply it by pi over 180, that will give you whatever you need in radians. That's how we convert to radians. So I'm going to multiply it straightforward by pi, and I divide the answer by 180. That gives me x minus 2 equals 2.37 radians. And then if I add 2 to both sides, that gives me 4.37 radians. So I'm done with the first one. So this answer that I got, that's really what I want for that angle. Call it alpha. So think about this as alpha. But at the end we need x. Now I need another angle. How do I find the other angle? So let's do this. The other angle is going to be somewhere here, kind of like by symmetry. So how do I find that angle? The way to do this is that we can go back and find cosine inverse of -5/7. Exactly what I just did earlier. And remember, it gave me 135.58 something. If I subtract that from 180, okay, that gives me this angle here because that's 180. So 180 minus the 135 something, that gives me this angle here, which is 44.40, about 42 degrees. That will be equivalent to this 44.42 degrees. It works like this all the time in cosine by symmetry like this. So now if I want to find this angle here from when it starts at 0 degrees all the way down here, what is it? It's going to be 180 plus this. So it's going to be whatever I just got, add 180 to it. 180 to it. That gives me about 224.42 degrees. And right away, I'm going to multiply that by pi over 180, as I'm doing right now. So then, this gives me the x minus 2, the second case. Let me write here 224.42 degrees. And that's in radians is 3.92. If you add 2 to both sides, you get 5.92 radians. And I should stop here because it says 0 to 2 pi. So the next one would be like hitting back at at 135.58 degrees. You don't have to do that because that exceeds 2 pi. So that's how you see the answers are not in terms of pi because I use the calculator. But you can convert them, like keep them in terms of pi if needed. You know, if you put the 224.42 degrees and divide these together and multiply by pi or keep it as pi, then you can get some number pi radians. That's okay. So either one should be fine. Either one should be fine. The next example, can they ask us to solve quadratics in trig? The answer is yes, they can. And as we learned in quadratics in algebra, if I have quadratics, let's restrict the condition on this 0 to 2 pi. So if we have quadratics, what we do here is we always bring everything to one side. Make sure you set it equal to 0. So 3 cosine x plus 1 equals 0. And what we need to do here is we need to factor this out quadratic wise. Or if you think, oh, that looks difficult, what am I going to do? You can you see on the side, cosine x equals u. And substitute into this equation. You got 2u squared plus 3u plus 1 equals 0. And then what can we do next? We can factor that equation as 2u plus 1 and u plus 1. And you can test it out. It should work. So then instead of u, I'm going to put cosine here. So cosine x plus 1, cosine x plus 1. So I got two factors. In order for this product to equal to 0, either the first one has to equal to 0 or the second one has to equal 0. So now I got kind of like two separate equations. So let's keep this the same, equals -1. Dividing by 2 gives me -1/2. From there, subtract 1 on both sides, you get -1. So what's the smallest angle? Its cosine is negative. So that should fall somewhere in the second quadrant. In that case, the smallest angle for this is cosine. Let's see. As I showed you earlier, I remember it by dropping the negative 1/2. What's 1/2? Which angle is cosine 1/2? Cosine 1/2, that's 60 degrees. 60 degrees. Or pi over 3. But I need the one in the second quadrant. Just remember the symmetry, pi over 3, pi over 3. So it's pi minus, because the whole thing minus pi over 3. This is the pi over 3. So that's 2 pi over 3 or 120 degrees. The other one, cosine x, the angle is cosine -1, that's easier. That's just pi, cosine pi. So now we're gonna finish it up here. Based on the formula we gave you, x equals, so alpha equals beta plus 2k pi, or x equals negative alpha plus negative beta plus 2k pi, k integer. Here, x equals pi plus 2k pi, or x equals negative pi plus 2k pi. Remember, there's a condition on x. It says has to be 0 to 2 pi. So let's see. If I take k equals 0, k equals 0, of course here k integer. If I take k equals 0 in all of them, in the 4 equations, the first one I get 2 pi over 3. Next one, negative 2 pi over 3. This is not acceptable. It has to be 0 to 2 pi. The next one is pi. The next one, negative pi. This is not acceptable. So I got 2 solutions so far. What about if I take k equals 1? K equals 1. For the first equation is going to be exceeding 2 pi. The next equation would be negative 2 pi over 3 plus 2 pi. What is that going to be? 6 minus, that's a 4 pi over 3. That's okay. If I put it in the ones on the right side, that will be pi plus 2 pi. That's more than 2 pi. But the other one would be negative pi plus pi, plus 2 pi, which is pi, but it's already here. So I already have pi here. And I have this and this. 3 solutions so far. What about if I take k equals 2? That will be more than 2 pi for all of them. What about negative 1? Negative 1, that will make it smaller than that. So the x values that we get to that given equation are 3 of them. 2 pi over 3, pi, and 4 pi over 3. Sometimes people look at it this way. If it's linear and I'm working only from 0 to 2 pi, we might get only 2 solutions. If it's like quadratic, we get 4. How come we get 3 here? What happened is the pi is duplicated, like pi in 2 equations, but we don't have to repeat them more than once. So we can just keep it like that. Now, are there any other solutions to this? Are there any other solutions? Can we test everything? Like, did we check everything? K equals 0, k equals 1. Everything looks good, right? So we got 3 solutions, only 3 solutions. One last hint. Let's call it note here. While solving, this is a common mistake. Trig equations in the form, let's say in this form, tangent, let's call it theta minus 2 cosine theta tan theta equals 0. Do not, and I really mean it, do not divide by tan theta, because that tan theta could be 0, so we can't divide by tan theta. Instead, to solve it, we need to take tan theta out as a factoring. That will leave 1 minus 2 cosine theta equals 0. And then we do not ignore that tan theta, so we have to solve it. So set tan theta equals 0, or 1 minus 2 cosine theta equals to 0. Solving for cosine theta here should be easy for everyone. And then we are going to find for the first equation, tangent theta equals 0, what are the values of theta that are equal 0? Let's say we are working 0 to 2 pi. So over 0 theta, let's say 360. When is theta, which angle is tangent is 0? We know from the table or the unit circle, 0 is one of them and 180 degrees, these 2 angles for this one. For cosine, which angle it's cosine 1/2? Cosine 1/2, that's 60 degrees. So then we can use the formula I gave you earlier, either 60 plus 360k or negative 60 plus 360k. Always specify k an integer. K is an integer. So to finish that up, we can take k equals 0 theta would be 60. I don't need the negative 60. If you take k equals 1 for the first one, that will exceed the 360. But for the second one, theta would be negative 60 plus 360. That's 300. So we have two solutions on this side and two solutions on the other side. So please make sure not to divide by tangent theta or any trigonometric function, because any of those functions, they can be zero. They can have a value of zero, and we are not allowed to divide by zero in mathematics.